Hello, this is question 3 on your November 2021 Edexcel AS paper. It's a Pulley question. So you have a ball P of mass 2m, is this one here, attached to one end of a string, then another mass which is 5m, the other side. You have a smooth pulley, the string is inextensible like in all your questions, and the system is held at rest. P is 2h from the floor or the ground, and Q is at h, and the system is released from rest. Q doesn't rebound when it touches the ground, and P doesn't reach the pulley, because when you release this from rest, this one is heavier, so it's going to move in this direction. So when this is released from rest, the pulley turns away clockwise, so this particle is moving down with acceleration a, and P is moving up with an acceleration a. It's the same because the string is inextensible. Balls are modest as particles, string light inextensible, pulley small and smooth, and resistance is ignored. And then the first thing we have to do is write down an equation for P and an equation for Q. That's how you are going to start all the pulley questions, even if they don't ask you. You will need those equations. So first, I'm going to draw the forces. So in P, I have a tension up, which is the same that in Q, because the pulley is smooth. And here I have 2mg, so the weight, and here I have 5mg. Those are the forces that are acting. So if we write the equation of motion for P, for example, first, so for P, and to write the equation of motion, remember I'm doing resultant force is mass acceleration. So for P, which is moving up, resultant force is going to be T minus 2mg. So if it's moving up, it's because this one is bigger. So we are going to write this one first. T minus 2mg. T minus 2mg is going to be mass, which is 2m, acceleration. And for Q, it's the other way around because it's moving down. 5mg is greater than t, so my resultant force is 5mg minus t. 5mg minus t is the mass, which is 5m, the acceleration, which is the same. So these are the equations of motion for P and Q. So this is part A. Then B is the long one. They say, find in terms of h only the height above the ground at which P first comes to rest. So P is this one here. So what is going to happen is going to move, this one is going to move h down, and it's going to stop because it says it doesn't rebound. So when this stops, the tension is gone. It's like if I have not a string. So after this one moves h up, it's still going to move up, like if it's projected up with a velocity, but I don't have any more forces. So this one is moving like with two different motions. The first one is an accelerated motion up, and then the second one is decelerated until it stops. So we're going to find both of them. And if we need to find the height, means we have to find a distance, we are going to use Subat equations. So for the first part, I know it's going to move h up, yeah, because it's what this one moves down. After that, I need to find the height. To find the height, what we are going to do is to find the final velocity of this first motion, because this is going to be the initial velocity of this one. So I'm going to apply Subat to both parts of the motion. So for the first part, I don't know how you want to call it. It doesn't matter how we call it. But if we apply Subat, we know the distance is going to be h. The initial velocity is 0 because it's released from rest. The final velocity is what we need precisely to find the initial velocity of the second part of the motion. The acceleration, we don't have it yet, but we are able to find it. And we don't need the time. To find the acceleration, we are going to use these two equations because we have two equations with two unknowns, the acceleration and the tension. So from here we can find any of them. We don't need the tension, but we are going to find the acceleration. So if, for example, I add them, I will get rid out of t, yeah? So I can get rid out of those two. Let me put that down. So I have 5 mg minus 2 mg is 3 mg, and then 2 ma plus 5 ma is 7 ma. I cancel m, so my acceleration is going to be 3/7 of g. Yeah, we don't need even to find the value. So this acceleration of the first part of the motion is 3/7 of g. And I'm going to use a Subat equation without t. That Subat equation is this one. Remember, you have them in the formula booklet. This one has no t. So v squared is what I need. U squared is 0. And then 2 times a, which is 3/7 g, and times s. So v squared is 6/7 gh. This is the initial velocity of the second part of the motion. So after we don't have tension anymore, the acceleration is going to be different. It's going to be deceleration, and it's going to be only the gravity. So after this moves up h, and I don't have the string anymore, this is going to just be projected up and then stop. So for that second part of the motion, I'm going to apply Subat again. So if I write this, I need now s. This is the s that I'm looking for. The initial velocity is the one that I just found. Final velocity is 0 because it's stopping. Acceleration is just the gravity, and it's going to be down. So if I consider, for example, positive up, my acceleration is going to be negative. It's deceleration, and I don't need the time. So again, I'm going to use the same equation. If v squared is 0, u squared is 6/7 gh, and then minus 2 times g times s. And I need s. So from here, s is 3h divided by 7. So they are asking us the height above the ground. So initially it was 2h from the ground, then it moves h more while this one goes down, and then it moves the bit that we just found. So we have to add the 3 heights. Yeah? So the total height is going to be 2h plus h more plus 3h over 7, and this is going to be 24h over 7. Yeah, that's the total distance in terms of h. The last couple of things is state one limitation of modeling the balls as particles that could affect your answer to part B. Part B is an h. So if this is modeled as a particle, it won't have a shape, it won't have a volume. So it's like a dot moving. And a dot will move h, but maybe if I have a shape, this is not h, so this it says above the ground. Yeah, I would say the height moved, but the particle maybe is smaller than h, or even bigger. It could be, no, I don't think it could be bigger, but it could be less than h. Yeah, if we count the shape of the particle, if we count the shape, for example, if we take into account the shape, the height or the distance to the ground, it wouldn't be h probably. The distance would be different. And the last thing, they say, in reality, the string is not inextensible. State how this would affect the acceleration of the particles. So remember, when we model the strings as inextensible, the acceleration of both of them are the same. That's what we are using here. So state how would affect the acceleration of the particles. They might be different. Yeah, acceleration of each particle will be different, or might be different. Yeah, so this is quite standard questions. Yeah, I think the important bit is this one. So for these Pulley questions, when you have one particle that hits the ground, or one string that gets loose or just breaks, you have to imagine what is happening, because that will help you. Yeah, and that's all with this exam question.